In this video, we will discuss some interview questions and answers for the product design engineer. Okay, so here in this video means a detailed answer we will discuss so that you can directly remember those questions and understand the principle. Okay, so those questions are very important for the product design engineers. So let's start. Okay. So first question is, can you walk us through your design process? Means here the recruiter is asking what is mean by means what design process you followed, okay, in the previous organizations. So generally these type of questions you will face for the experienced people, okay, who have the more experience in the design, okay, like 5 years 6 years like that. Okay, so here we need to capture these are the points like so first while designing the process, the process is like that. We need to define the problem and design requirements. So problem and the design requirement we need to understand first. Then we will research and gather the information on the existing product and the technology available in the market. Okay, then develop the concept. There is a concept modeling. After that we will start after gathering the information and the capturing the design requirement. Then we will work on the concept design. Then we will create the initial concept and the drawings. Okay, then we will evaluate and refine those concepts based on the feasibility, cost and the performance. Okay, so this cost, performance and the feasibility points will take into the consideration and fine tune the development concept. Okay, so here after that we need to create the detailed design using 3D modeling software. Okay, then we will complete detailed drawing and the detailed modeling we will prepare after finalizing the concept. Okay, so at the concept level we will share the number of concept. Okay, in that we are finalizing only one. Okay, based on the different factors like the load condition, availability of the machines and the aesthetics and also performance level and the cost level. So based on that we will finalize the concept. Okay, and after that we'll start the detailing of the modeling and the drawings. Okay, then we will conduct the simulations where we analyze the load condition, how that product behaves under the load condition, that we will get from the simulation. And we will after that we'll go for the prototype test, and after getting the result from the prototype and the simulation, we are from that result we are updating the model and the drawings. Okay, then we will prepare and release the final drawings for the production. Okay, so this one is the process, step by step process I have followed in the last organization, that like that you can explain. Okay, the next question you may face like how do you ensure your design are manufacturable? Okay, so I ensure that my design are manufacturable by taking into account the manufacturing process from beginning of the design process. Okay, I work closely with the manufacturing team to understand the capability and the limitation of the process and design my product accordingly. Okay, I also use the design for manufacturing principle such as minimizing the number of parts and simplifying the assembly, and to make the manufacturing process more efficient and cost effective. Okay, so this one is the answer. So you can ensure your design in manufacturable. So you have the tool design for manufacturing DFM. Okay, where we are considering all the points like profile of the part or the availability of machines, and we are discussing with the manufacturing team, and we are taking the feedback from the manufacturing team, and also from the senior members, and we after that we are finalizing the parts. Okay, so in that way you can take the you can set up the meeting with a different stakeholder, and you can take the feedback, and after that you can update those feedbacks in the design. That way you can ensure your design is manufacturable. Okay, and also you need to follow the general design guideline first. Okay, so while designing any component you should follow the general design guideline. So already I have uploaded the videos on rotational molding, injection molding, sheet metal, casting, general design I already uploaded in the my YouTube channel. Okay, so those design guideline also you can follow. Those design guidelines are the general design guidelines that you should follow first. Okay, and after that you can connect with a different stakeholder and the leads or your manager. Like you can take the feedback from the different members. Okay, and after that you can confidently say that this product is manufacturable, where you can consider different factors like rounds, draft, and ribs thickness. Okay, and DFMA principles that in so those accordingly you need to you need to go for the design for manufacturability. Okay, so third question you may face, like how do you prioritize design requirements when they conflict with each other? Okay, so suppose in critical situations, okay, where two requirements or design requirements are conflicting at each other, so then how you are prioritizing these requirements? Okay, which requirement you take first and which requirement you take at the last? So here is the question for the experienced people. Okay, so when designing requirement conflict with each other, I prioritize them based on the overall objective of the product. Okay, so this line is very important. So based on the overall objective of the product, this one is a very important. Okay, based on that we need to prioritize. So for example, if the objective is to create the low cost product, then cost may be given higher priority over other design requirement. Okay, however, if the objective is to create the high performance product, okay, then the performance may be given as the higher priority. Okay, so you need to understand the requirement first. Okay, so I also consider the impact of each design requirement on the user experience and the long-term success of the product, that you need to add at the end. Okay, so next question is can you explain the difference between static and the dynamic loading? Okay, so this also generally question you may face. So because this one is related, suppose you are working in for the automobile industry, so at that time you may face this question. Okay, so here the difference is asking about the static and the dynamic loading. Okay, so the static loading, so in the name itself static. Okay, static loading is when load is applied on the structure or the material and remains stationary without changing over time. Suppose that product, okay, or that part is at the stationary, it's not moving anywhere. At that time the load coming on that part or the product is the static loading. Okay, so the product or the part is not moving anywhere and under that product is under the loading. Okay, so that load is the static load. Okay, and dynamic load, so dynamic load is the reverse. Like dynamic load on the involves the load that varies over time. Suppose that product under the under the running condition or the location is varying over the time, so such loading is called as dynamic loading, because the load coming on that product is under the under the running or change that product location is changing over the time. Okay, so during the motion or during the running, the load coming is the dynamic loading, like vibration, impact loading, cycling loading. These are the dynamic loading. Okay, so the static loading typically cause the permanent deformation or the failure. Okay, and the dynamic loading can cause the fatigue failure and the stress cracking. So this point you can add at the end. Okay, first you need to explain static loading and the dynamic loading, and after that you can add additionally what are the impacts. Okay, static loading means cause the permanent deformation or the failure. Okay, and the dynamic loading cause the fatigue failure or the stress cracking. Okay, that you need to add at the end. Next question is, how do you ensure your design meet the safety standard and the regulations? Okay, so to ensure that my design meet the safety standard and the regulation, I stay up to date with the latest industry standard and the regulation. Okay, so this point we need to at the first only we need to add this point, that we need to stay up to date with the industry standard and the regulation. Okay, and I work closely with the safety and the compliance team. Okay, I also perform rigorous testing and analysis to identify and mitigate any potential safety hazard. This includes the conducting simulation, physical testing, analysis of failure method. Okay, so while working on any product or the any part, okay, so you are working on that part, but after complete design we need to send for the testing. Okay, for the simulation we need to send the complete part and the product. Okay, so we need to gather all the information from the simulation team, from the testing team. Okay, we need to gather the information. Okay, and we need to we need to get the feedback from the particular team, like from the simulation team, from the testing team. Like there are vibration testing, physical testing, electrical testing, or the lubrication testing. Those all the test is the whatever test we are performing on the product, we need to gather all the information, and we need to take the feedback from the respective team, and we need to accommodate the changes as per the result from the simulation and the testing. Okay, can you describe the challenging design project you work on and how you overcome the obstacle? So generally for the experienced people, like from 8 to 10 years, you will definitely face this type of questions. Okay, so here the recruiter want to understand how you how you will face the design, how you will face the obstacle in the design. Okay, and how to overcome the challenges in the design. Okay, so here you can answer like this, like on one challenging project I worked on was designing the complex mechanism for the medical device. Okay, the mechanism had to meet the strict performance requirement while being easy to use for medical professional. One of the main obstacle was designing the mechanism to be small and compact. So this one is the obstacle we are mentioning, like we need to design the small and the compact. Okay, while still being robust enough to withstand the repeated use. Okay, these are some challenging points we are adding. Okay, to overcome this challenge, I conducted the extensive testing analysis to identify the potential failure mode. Okay, then iteratively means after performing number of iteration and the design change, I improved the design until it meet all the performance requirements. Okay, so this is just an example I am giving. Okay, for this particular question you need to add your experience. So on which project you have faced the challenge and how you have overcome that challenge. Okay, so you need to say for this particular question you need to add after performing a number of iterations, like 5 iterations, 10 iterations, you will get the proper result. Don't say like this in a first attempt. Okay, in a first attempt you have completely overcome the challenges. Also you need to add, I took the different feedback from the different team, like I connected with the manufacturing team, I connected with the stakeholders, I connected with the senior members. Likewise I took the different feedbacks from the different team. So you need to add those points also, and based on your project experience you can answer these questions. Okay, next question is, can you explain how you would design a product for assembly? Okay, so here particularly asking about the how means that product behaves under the assembly. Okay, so here designing for assembly, so this is one term where design for manufacturing and the design for assembly, so like a DFMA. Okay, so design for assembly is the important aspect of a product design. Okay, as it can significantly impact the manufacturing efficiency and the cost. So to design a product for assembly, I would consider the following factor. So here I am explaining. So these are the factors you can consider, like minimizing the number of part. Okay, so whenever we are our part we are going for the assembly, so at that time it should so we should use the minimum number of part. Okay, so that we can save the cost. Okay, minimum number of part and the common part, and this common standard part we need to use. Okay, so the minimum number of part reduces the number of part and simplifies the assembly process. Okay, and there is it will avoid the risk of error and the defects in the assembly process. Okay, and we need to use the standard part and the standard component, like in the fastener, like M12 bolt, M8 bolt, washer, sleeves. Okay, some clamps are there, different component pins. So that those components means standard components we need to accommodate in the assembly process or the design. Okay, so using the standardized component reduces the number of unique parts that we need to assemble and simplify the assembly process. Okay, if you use the standard part, you no need to design the new components, no need to manufacture the new components. So you are saving the time and saving the cost when you use the standardized part. Okay, so always try to use the standardized part and the common components in the design. Okay, design for accessibility. Okay, so the designing the part that are easy to access and assemble, and reduces the assembly time and the complexity. Okay, so while designing components we need to perform the tool access study. Okay, so we need to, in the CAD model we need to use the tool we are using at the manufacturing, available tool we are using at the factory or at the assembly point. So that tool we need to perform, means we need to check at the design level only. Tool access study we need to perform, that whether that tool is interfering with components or any means access issue in the assembly, that we need to check. Okay, so tool access study we need to perform in the assembly. Okay, before that complete assembly or the complete product is assembled at the factory. Okay, so design for tolerance, so ensure that the part have tight tolerance and reduces the risk of misalignment during the assembly. So in the on the means part level or at the assembly level drawings, we need to add the tolerances so that the misalignment in the assembly should not be there. Okay, so yeah, so these are the points that means is used for means available, we can think for the design means design product for the assembly. So at the assembly point of view, we need to minimize the number of part, use of standard part and the components, and the design for accessibility, like we need to perform the tool access study, and design for tolerances, that we need tolerances we need to add in the drawing. Okay, the next question is, can you tell us about your experience with the CAD software? Okay, So for particularly for the product design engineer, suppose you are designing the product in the Creo software or in the CATIA software or SolidWorks or any software, okay, that CAD modeling software, okay. So you need to add your experience, like you need to say I have 5 years experience in the CAD, like in the particularly I have experience in the sheet metal tool, or in the surface modeling, like in the plastic component design or the casting component design. So likewise you can explain about the software skill and you can rate your skill, okay. Okay, so like the here I have given the example, like I am proficient in a several CAD software program including SolidWorks, Autodesk, Inventor, Creo, CATIA. I have used the CAD software extensively throughout my career to create the 3D model and drawing, and conducted the simulation and communicate design concept with the cross-functional team. I am also familiar with the PDM and PLM software. Okay, so this is the additional points I am adding. Okay, okay. So PLM and PDM software I have used, like a wind chill. Okay, like you can add. Okay, so because in the company, okay, at the organization level we are creating the number of CAD files, okay, the files or the CAD data we are creating, but where we are saving these files, okay, where we are storing this file, that tool also we can add, okay, we should add, okay, like a wind chill I'm using, okay. So I'm aware about the wind chill software also, okay, like different data storing softwares are there, or you can say different SAP softwares are there, where we have all the data we are storing for the for the different fields, like for inspection, manufacturing, for the design. So all the at the different state, all they are using the same software. So like SAP software I use. So different software skill you can add here, so that you will get an impression, okay. You will got after that they you know the CAD software, you know the wind chill or PLM software, okay, and you know the different softwares like Cola, okay, like SAP software. So based on that your experience you can add here, okay. Here is the, can you give an example of time when you had to use the creative problem solving to come up with the solution, okay. So so this one is for experienced people above the 10 year, okay. You may face this question, okay. So you can add the previous experience, that having the, suppose you have created the created the component or the machines where you have solved the number of problems at the suppose in the manufacturing or the for the component process, you have faced the different problem and you have overcome with some solution, okay. So you have provided the solution and you have overcome the problem. So that based on your previous experience you can answer this question, okay. So here you can take the screenshot. Here I have just explained the in the text, okay. So can you explain the difference between tolerance and fit in the mechanical engineering, okay. So here we need to answer regarding the tolerance and the fit. So this one is a very important for the fitment of the product and the for the drawing, okay. So the tolerance and fit, both important concept in the mechanical engineering. Tolerance refer to allowable deviation from the specific dimension, okay, that is nothing but the tolerance, and it determines the how much variation is acceptable in the final product. And fit on other hand refer to relation between the two parts that are intended to be assembled together, okay. So fit is related with the assembling of the two parts, and whereas in the tolerance is nothing but the deviation from the actual size of the feature. Okay, so whether how much variation is, so in that there is an upper limit and the lower limit of the tolerance. So within that limit we are accepting the parts, that is nothing but the tolerance. And fit is related with the two components, the fitment of the two components. Okay, so the fit determines how tightly or loosely the parts will fit together. Okay, so the tolerance is used to ensure that the fits are within the acceptable range of variation, where the fit used to ensure that the part fit together properly during the assembly. So on the fit side we have the clearance, generally we have the clearance fit, interference fit, like we have the fit. So generally the clearance hole we are adding. Okay, likewise, or you can see at the threaded portion we have the interference fit. Okay, can you explain your approach to designing the product for manufacturability? So here we have already discussed that. Okay, so for to design the manufacturable products, okay, so we need to follow the general design guidelines. Okay, for any product design, like for sheet metal, plastic, casting, rotational molding. So for any product design we have the general design guidelines. Even for pipings, okay, for cablings we have the general design guidelines. So how much length we need to keep, how much thickness, minimum thickness requirements, or the uniform thickness requirements. Likewise, there are the general design guidelines, draft, parting lines. So that should be we should consider at the design stage, and we need to follow that general design guideline. And after that, the important point is we need to connect with the different stakeholder. Okay, and we need to connect with the manufacturing team. Okay, so that we can we need to take the feedback and we need to update in the assembly. We need to accommodate that feedback into the design. Okay, so here you can read here, and we need to here like a design for scalability, minimum complexity. So if you follow the general design guideline, so that product or the part should be manufacturable. Okay, can you describe a time when you had to work with a cross-functional team on the design project? Okay, so here this question is for the experienced people. Okay, like up to 8 to 10 years. So here recruiter want to understand how you are connecting with a different stakeholder. Okay, so do you have he's checking the employee having the interactive with a different team skill or not. Okay, interactive skill should be there. Okay, so at that time you can use the previous experience, like I have connected with the manufacturing team, I have connected with the supplier, I have connected with the other team members. Like suppose I am working in the designing the, suppose I am working in the engine domain. Okay, so so I have connected with the transmission team, I have connected with the steering team. Likewise, you need to you need to add your experience here. Okay, and what are your learnings from those teams, that also you can add here, because here recruiter want to understand your learning approach, and what learning approach from the different team, and how you are connecting, and your interaction skill he want to check here. Okay, so you can add the previous experience. Can you explain the difference between ductile and the brittle material? So this one is a simple questions. Okay, so the ductile material are those that can be stretched or deformed without breaking, such as rubber or the steel. Okay, and whereas in the brittle material do not deform much before fracturing. Okay, like a glass or ceramic. So in the ductile material deformation will be there. okay, for the ductile material. So like a rubber and the steel, you can understand from this. Okay, and for the brittle material like glass and ceramics, so there will be no deformations. If you directly stretch, it will directly fracture. Okay, so friend, that's it for this video. If you are the experienced people, you miss you note these all these questions and prepare for this question, because from this list of this question you may face 2-3 questions for sure. Okay, so you need to prepare for these questions, and you may crack the interview. Okay, so thank you for this video and best of luck for the interview. And subscribe this channel, hit the bell icon. And so thank you for watching. See you in the next video.